Hello, discrete math students. This is Mr. Lewit. This is going to be our last learning video for the semester. Today is Saturday, July 25th, and you should know that the course ends on Thursday, July 30th. So, yeah, this is our last video. I hope it's been a good experience for you guys. I realize it's been a lot of homework, but remember the homework is 50% of your final grade. And my theory, my philosophy of education is that your homework is ultimately more important than quizzes and tests. I mean, maybe there are some exceptions to that, but I think in general, you're assuming you're not cheating, assuming that you are really doing the homework yourself. I think the homework, your success with the homework, says more about your understanding of the course material than quizzes and tests. Assuming, of course, again, that you're doing most of the homework yourself and you're not just copying answers from the internet or answers from someone else. Okay? So we're all adults, we're all, if you're cheating, that's on you. I'm not teaching elementary school kids. So if you're getting answers from another source, that's your responsibility. And, maybe in some future course, you'll pay the consequences for that. You need to do the homework on your own as much as possible. Okay. Okay, but so I've been getting a lot of questions, a lot of emails from students who are having difficulty with the knapsack problem. Now, I'm not actually going to show you the solution right now. I will email you my solution the day after the assignment is due. All right, after the assignment is due, I will share my solution with everyone in the class. So excuse me, I don't feel comfortable solving the problem for you because then I'm basically doing the homework for you. What I will do is I will try to guide you through some preliminary steps. And then it'll be your responsibility to wrap everything up, and to make it work, for the most general case. But let's just do an example. Let's do an easy example, okay? Let's say the maximum weight is, how about 20? Okay, we don't know what the units are. 20 pounds, 20 kilograms, 20 grams, 20 tons. It really doesn't matter. Okay, we're not interested in units. This is not a chemistry or physics class where the units are actually very important. We're just interested in the numbers right now. Okay. So let's say that my list of weights is going to be something very simple, like 5, 5, 5, 5, 5. Okay? So we have 5 items, and each one has a weight of 5 units. Whatever the unit is, it could be pounds or grams or milligrams or kilograms or tons or metric tons, ounces, whatever unit you decide, okay? So obviously we do have a problem because we know that we can't stuff all 5 items into the knapsack or backpack, right? You're going to have to choose 4 of them. It could be the first 4, it could be the last 4, it could be the first one and then the last 3. So obviously, you're going to pick 4, you're going to pick only 4 and leave 1 behind. So how do we make that decision? Okay, profits. Let's make this very simple. Okay, we'll do 10, 1, 3, 4, and how about 6? Well, we don't have to be computer scientists or mathematicians to figure out the answer. The answer is obviously going to be take the first item, take the third item, take the fourth item, take the fifth item. You're going to leave the second item behind because it has the lowest value. Okay? So let's see. 10 plus 3 plus 4 plus 6. Okay, so 23 is going to be the maximum profit, and that's really easy to figure out without a fancy program. The thing that you have to remember is that this problem is very easy because all the weights are equal. All the weights are equal. All right, and if all the weights are equal, then anybody could figure out the solution, but let's pretend that we don't know the solution. We really know the solution. The solution actually is going to be 1, 0, 1, 1, 1. Okay, so we leave behind the second item. We take the first item, we take the third, we take the fourth, and we take the fifth. Okay? And we leave behind the second item because it contributes the least profit. Does that make sense? Okay, but let's pretend that we really don't know the answer. Let's pretend, I'm not sure that the answer is 1, 0, 1, 1, 1. And how did Mr. Lewit figure that out? And, so let's go through this very slowly. And then you're going to have to write a function that will handle any maximum weight, any weights list or weights vector, call it whatever you want. In Mathematica, it's called a list. In some languages, it's called an array. And in some languages, it's called a vector. Call it whatever you want. List, array, vector, they're all kind of sort of the same thing. All right? They're not technically, from a computer point of view, they're not really exactly the same. But from the programmer's point of view, you could think of lists and vectors and arrays as being very, very similar. Very, very, very similar. Not exactly the same, but very similar. All right? Pardon the sore throat. Okay, so let's get going. How are we going to figure this out? So let's see. All combinations, tuples, 0, 1, and why 5? Because 5 is the length of my weights vector, and it is also the length of my profits vector. Let's see what this gives me. Oops. Okay. Excuse me. What is the length of all combinations? The length of all combinations is 32. I could also figure it out this way. All combinations length. Why is it 32? Because 2 to the power 5 is equal to 32. Okay. Okay, so the next step is, the problem here is I can tell you which one right away. We know that the last combination is not going to work. Why is the last combination not going to work? It's not going to work because the weight of the last combination is 25. And I can see here that the maximum weight is 20. So, but how do I do that officially? What is the programmer's way of solving that problem? The programmer's way of solving that problem is very simple. If I have something like this, 1, 1, 1, 1, 1, okay, and 5, 5, 5, 5, 5, take the dot product of two lists or two vectors. It's 25. So why is it 25? 1 times 5 plus 1 times 5 plus 1 times 5 plus 1 times 5 plus 1 times 5. We have 25. 1 times 5 plus 1 times 5 plus 1 times 5 plus 1 times 5 plus 1 times 5. Okay, it's 25. It's very simple. So what I have to do now is filter out the combinations that simply are not going to work. All right? So feasible feasible combinations is equal to, you can use select or cases. I have a lot of experience using cases. I have less experience using select, but I think select really does the same thing as cases. So cases, all combinations. And what should I call each combination? I'll call each combination combination. Okay, this is my variable. That's a little verbose. Instead of well, how about just C? C for short. Okay? The dot product of C and weight should be less than or equal to 20. Okay, let's see what we got. That's really weird. Okay, so what happened? Oh, okay. I did not. Okay. This is not the correct name. There we go. That's the correct name. Weights. Did you see the mistake, guys? I called it weights. It should be the weights list. Okay. Shift enter. Why am I still getting an empty list? How strange. Very, very strange. Hold on 1 second. Very strange. Okay, hold on 1 second. Cases, all combinations. Well, first of all, let me look at all combinations. Okay, that looks fine. Is there a problem with cases? I think my syntax should be okay. Okay, no, I need the underscore. The dot product of C with weights should be less than or equal to 20. Okay, very, very weird. Hold on 1 second. Let's see. Cases 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And let's say C is greater than 7. Yeah, so the syntax works just fine. My cases syntax works fine. So okay, so this is so strange. Dot product of 0, 0, 0, 0, 0. Weights. Okay, so I think I see what happened. Oh, you know what happened? This was not defined. Okay, that was not, okay, I did not define weights. I did not press shift enter. Okay, weights was never defined. Weights was never defined. I was too busy talking. So, yeah. There we go. I was too busy talking. Let's try this again. I'm going to come up here. Guys, I'm right over here on this line. Okay. Let's press shift enter again. There we go. That makes more sense. I was wondering what is going on here. So I was so busy blabbing away that I forgot to simply initialize my weights list. Okay, duh. Okay, so I get the idiot award of the year. Okay, we've all done stupid things, right? Okay, so you can see almost everything is included in my list. You can see that almost everything is included in my list except the last combination, which has 5 ones. I mean, that's pretty, that's pretty obvious. Here, let me erase these. I really do not, I do not need them. Oh, and by the way, if you want to add a title, come up here to Palettes, Writing Assistant, Title Cell. Okay. My last video lecture for Math 144 students. Okay? And that's it. This will not evaluate to a mathematical expression because it's not a mathematical expression. It's a title. It is simply a title cell. It's a title cell. Okay? That's it. Okay, let's go back here. So we need to store this in a variable. I'm going to call it feasible combinations. There we go. So the next step is we have to choose which combination is going to produce the largest profits. We need to know which combination is going to produce the largest profit. So there are several ways of going about this. There's several different things that you can do. I happen to like folding. With folding, you're going to use a function of 2 variables. And what it's going to do is first it compares these 2 lists, okay? And then it's going to evaluate a result. It's going to evaluate a result. And then it's going to take that result and compare that result to these 2 lists. And then these 2 lists. And so on and so on and so on. You basically keep comparing adjacent pairs of lists until finally you compress everything down to a single value. So what we could do, there are different ways of doing this, but I'm going to recommend we do this. We need a function of 2 variables, which makes sense because I'm comparing 2 lists. I'm comparing 2 lists, okay? And then of course I compare these 2 lists, right? And then I compare this list with this list. And then I compare these 2 lists. And I keep making comparisons until finally everything is reduced to a single value. So what we're going to do is, let me see, the dot product. That's my dog, so don't worry about it. He's got a bigger mouth than me. I'm sure everyone heard that on the microphone. Jeez. Okay, so the joys of working from home, right? If the first list, let's do this. Wait a minute. No, wait a second. How do I, hold on 1 second. Now my train of thought was broken. Let me do this. Hold on 1 second. Hold on. This is the joys of live coding. All right, what I'm gonna do is this. My profits list, or well, I'll call it profits list. Okay, is equal to table. I'm wondering if I could just do this directly with a fold, but you know what? Let me do it this way. This might be easier. Table. Feasible combinations. I like the index K. I know everyone's hung up on I's and J's. I happen to like the index K. Use whatever letter you like. Dot product of feasible combinations K with my profits list. I did call it profits, correct? Yeah, profits is right up here. Okay, here, let me do that one more time. Profits is right here, yes. Okay. And K ranges from, I believe it's 1 to 31, but we're going to check that. What is the length of feasible combinations? That's 31. From the first two, or I could just type length feasible combinations. And it's probably easier to just do that. Okay? So these are all the these are the combinations with the profits. Okay, so if you have nothing in your knapsack, you have a profit of 0. If you put the last item in your knapsack, you have a profit of 6. If you put the second to the last item in your knapsack, you have a profit of 4. Blah 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 blah. Okay, you can see the whole thing right here. Now the fold is going to be very easy to do. So what we can do is this. Fold. Now remember, each of these items, hold on, let me highlight this. Each of these items has a first part and a second part. The first part is the combination, and the second part is the profits. Okay. If the profit of the first list is greater than the profit of the second list, return the first list, otherwise return the second list. So all I'm doing is I'm trying to find the combination that produces the maximum profit. This says if the profit of the first list is greater than the profit of the second list, return the first list or return the second list. We close that with an ampersand. Profits list, shift enter, and there we go. We can see that the best combination is 10111, and this is going to give me a profit of 23. But this is what we saw at the beginning. We saw the same thing at the beginning. We saw that because all the weights are equal, and the capacity, this is the capacity, hold on one second. This is the maximum capacity of my knapsack, right? So it makes sense that I can only include 4 items in my knapsack because each item has a weight of 5 units. And it makes sense that the only item that I would exclude is the item that has the least profit, which happens to be the second item. So the result, let me just go through something. Yeah, here you could just, instead of 20, you could actually just use the variable maximum weight, but it's going to be the same thing. Okay, so yeah, this is very intuitive. This result confirms our answer above. And by the way, do you have to use this form? No, you don't. You could also do it like this. Fold if the profit of the second list is greater than the profit of the first list, return the second list or return the first list. Profits list. I mean, you still get the same answer however you slice your bread. Okay, you're still going to get the same answer however you slice your bread. Could you do it another way? Mathematica offers many ways of doing something. I mean, one way of doing it, one way of doing it, I believe, would be like this. I have less experience with associations, but we could try this. We could do feasible combinations K, create a rule. The arrow, that magic arrow, is very easy to create. Excuse me. Dot product feasible capital C feasible combinations K. Actually, you know what? This really should be sorry, that should be a double square bracket. I'm just a little sleepy today. With profits, our profits are right up here. Okay, here's another way of doing this. And K goes from 1 to the length of feasible combinations. And we really want to create an association. In Python, it's called a dictionary. In Python, this is called a dictionary. In Mathematica, it's called an association. Okay. So the next thing we want to do is sort the dictionary. We want to sort the dictionary. And if you sort the dictionary will be sorted according to the values, not the keys. These are keys. These are keys. These are the values. So we can actually, let me make sure this works first. Yeah, it does. It works beautifully. So we can do, here, let's sort this. Okay, and then in order to change this back into a list, you would do normal dictionary. You would do normal dictionary, and then if you want to get the very last element, you would have to do -1, just like in Python, and that will give you the very the largest, that will give you the key value pair that has the largest value. This will return the key value pair that has the largest value, assuming, of course, that your dictionary has been sorted. And if your dictionary has not been sorted, you're going to be in big trouble if you do that. So actually, we could even store this in a variable. My solution. Okay, my solution is this. And if I just want the 23 extracted from my solution, I apply the rule. This is called a rule. This is a rule in Mathematica. My solution, 10111. Okay, why did I not? Oh, whoa. I'm doing this backwards. Sorry about that. 10111 according to the rule expressed in my solution. There we go. So this is the rule for transforming this combination into a profit. So what we have then is 10111, and I'm going to apply that apply the rule contained in my solution to that, and I will get my profit. my profit of 23. Now, I believe if you want the combination, only the combination, yeah, you could do that. You could do that, and that will give you, and actually, yeah, well, hold on one second. Yeah, you could do that as well. You could do that as well. So your combination, you could say best combination is equal to my solution, the first part of my solution, and then profit or best profit is equal to my solution. Oops, sorry about that. My solution 2. Or you could also say best combination and apply the rule my solution, and you still get 23, okay? So I really hope, guys, I mean, I don't think this is a super difficult assignment. Okay, I can think of stuff in Mathematica that is definitely much more difficult than this. So I don't think this assignment is really that difficult. It's a little challenging, but it really shouldn't be that bad. Okay. And once again, this is my last video, so I hope these videos have been helpful to you. And if they haven't, well, I apologize, but I'm doing the best I can do. I normally do not teach online. I'm not a super big advocate of online teaching. I prefer teaching face-to-face. So, online teaching is certainly not my favorite thing to do. In some ways, I think it's much harder to do correctly than to teach in person, where I can actually develop a real relationship with my students. Online courses are difficult because the student has to do a lot of the work on his own or her own. And that's really hard. If you're taking a live class with other students, then not only are you learning from the instructor, but sometimes what's even more important is you are learning from each other. You're learning from other students in the class. That's really important because some students actually learn better from their classmates than they do from the professor, but a lot depends on the student and the professor. But I as a student, when I was a student, I really didn't like online courses that much. I thought they were very difficult. I really preferred to go to school, 2 or 3 days a week, meet the other students in the class, meet my professor, develop a relationship with my professor, develop friendships in the class, study with my classmates over tea or coffee, go to Starbucks, spend 3 or 4 or 5 hours studying with friends in the class. Going to school isn't just about developing intellectual skills, it's also about developing social skills. And the social element of education is really missing from most online courses. Maybe not all, but I believe most. So it makes things much more difficult for the student. When I was a student, I really did not like online courses. Even if the professor was fantastic, and even if the textbook was fantastic, I felt I learned better in a face-to-face situation. But we all learn a little bit differently. So maybe your take on it is different from my take on it. But I'm just sharing with you my own personal feelings about online education. It has serious limitations, in my humble opinion. But because of the COVID-19 pandemic, well, we really don't have much of a choice. Okay, so hopefully this was a fantastic course for you guys. I hope you learned something useful. And I enjoyed it. I really enjoyed it a lot. I enjoyed your emails. I enjoyed chatting with you and getting to know some of you. And hopefully you will take away something really positive from this experience. I really hope so, okay? All right, guys, take care. Bye for now.